Okay, so we are going to start with solving equations. The difference between solving equations and simplifying expressions is that you're going to notice that they have equal signs with them, so it's not just combining your like terms or distributing. So we are actually solving for an actual value. I'm going to go ahead and actual number or value. Okay. Now, you're going to see terms that look like X's. They're going to have B's or A's or C's. Okay. All they are just letters, okay, that represent some number. Okay. They are your unknowns. You do not know what that number is. Okay. Now the key here, the goal of all of this is to get your letter by themselves. Okay, so get your letters by themselves. Okay. Now in this case, we're not going to have multiple letters. We're just going to have one set, but eventually we will have more. All right, so we're going to start off with an easy one. X plus 2 equals 4. Okay. Now, I like to color code things, so I'm going to draw my train tracks. Again, you cannot cross the train tracks unless you do something to both sides. Now, if we think about it, some number plus 2 is equal to 4. So you think in your head, okay, well, what could that number be? And there's a lot of different answers. But ultimately, we want to get all of our letters by themselves. All right, so you're thinking about x plus 2 equals 4. I want to leave my x where it is, and I want to get rid of my positive 2. So to get rid of a positive 2, you have to think of it in terms of money. If I have $2 and I spend $2, then I'm going to be left with $0. So we're going to take the opposite of adding 2. Well, the opposite of adding 2 is subtracting 2, which becomes a big 0, so I put a Z. But what you do to one side, you must also do to the other side. We can't leave the other side hanging. Okay, so I'm going to draw my line. Now I'm going to bring my x down because we know that that's 0. We don't have to write it anymore. I'm going to bring my equal sign down, and then we think, okay, well, 4 minus 2 gives me 2. Okay, you can always go back and check this and say, okay, well, here's my parentheses. There's where my x is going to go. Plus 2 equals 4. So I'm going to take this and plug it in. Oh, look, 2 plus 2 is 4. So then, yes, we did it correct. Now, eventually, we're going to start adding to this, and I'm going to change it up a little bit by adding in a minus 4 instead of a plus, and let's see what happens. Okay, I'll go ahead and draw my train tracks. Okay, I want to get all my letters by themselves, which I have all my letters over here by themselves, so I'm going to cover it up and think, okay, if I have a negative 4 and I want to make it 0, the only way that we can make it 0 is by doing the opposite, by adding 4. Okay? Now, just like a scale, okay, that you might see in science, you have to be balanced, so I've got to add that 4 to the other side. Okay, well, negative 4 and a positive 4 becomes a 0. So then I can just bring down my x, bring down my equal sign, and then we think, okay, 8 plus 4 gives me 12. So my x equals 12. You can bring it back up here. 12 minus 4 must give me 8. My next example is a little bit different than what you've seen. We have our 2x equals 4. Now this is said a little bit differently. I have 2 times x equals 4. So some number times 2 is going to give me 4. Now you can also write it like this. This is the same thing, x plus x equals 4. That helps you think about it if you're estimating that number. So you have a number and it has to be the same for both, and it's going to give me 4. Okay. Now again, our goal is to get all of our letters by itself. I'm going to draw my train tracks. Okay, well, my letters are by themselves, but I have 2 of them. you want one of them. So the question for you is, how do I make this 2x become 1x? Okay. Now if you notice up here, you have the opposite. If I had a positive 2, I subtracted 2. If I had plus 2, I subtracted 2. If I had minus 4, I added 4. So we're going to do the same thing, but we're going to do the opposite of multiplication, which is division. So we're going to divide by 2. Whatever number is in front of x, you're going to divide by that same number. Okay, and the same thing is true because we want to make that 1x. So we think, okay, well, what's 1 times 1? 1. All right, and then 2 times 2, it's also a whole. So when we want to make this 1, we just divide by whatever number's in front. Okay. All right, with our railroad tracks, what you do to one side, you have to do to the other. So we're going to bring down our equal. So we have our x. It's okay if you put this as a 1x. And then our 4 divided by 2 is 2. Some people might write it like this. It's the same. Okay? And again, you can take that, plug it back in, and it's going to give you your same answer. Okay? All right, then we have our next example. This is going to combine them a little bit. 2x plus 4 equals 12. You're still going to create your same railroad tracks. Okay? You're going to say, okay, I need to get all of my letters on one side. Okay, so I have letters over here, but I want to get rid of this 4. So we think, okay, well, what's the opposite of a positive 4? A negative 4. Or what's the opposite of addition? It's subtraction. So we're going to subtract that. That becomes 0. And then we're going to have to subtract it over here on the other side. We bring down our 2x, our equals, and then we have 12 minus 4, which is 8. Sorry, my thing is shaking so much. So, to get 1x, not 2x's, we take the opposite of multiplication, which is division. So we're going to divide by 2, so that becomes a 1. And then we have to do the same thing on the other side. So we're left with x equals 8 divided by 2, which is 4. Now it gets a little bit more complicated when you start throwing in negative numbers, and that's okay. They're not that scary. The process is still going to be the same. So I'm going to go ahead and I'm going to show you this one. We have negative 2x minus 2 equals 14. So some number times negative 2 minus 2 is going to give you 14. Okay, so again, we put our train tracks. Okay, I'm going to cover up what I want to keep the same. I'm going to get rid of this 2. If I get rid of it, I need to make it 0. So the opposite of subtraction is addition. So that gives me my 0. And then I must add it to the other side. So we bring down our negative 2x, we bring down our equal sign, and then we think, okay, 14 plus 2 is 16. Okay, and again, I told you the process was still the same, but something's really scary about this. It's that negative sign. Okay, and we don't want a negative x, we want a positive 1x. So just like what we talked about earlier, you're going to take this and you're going to do the opposite. So the opposite of multiplication is division. Now we're going to take the whole thing, not the x, but the whole coefficient in front, and we're going to divide it. Now look, a negative on top and a negative on bottom gives you a positive. And 2 over 2 gives you a 1. Huh. I'm going to do the same thing over here. So then I have x equals, what is 16 divided by 2? It's going to give you a negative 8. Okay. All right, and here is our last example. X plus 2 divided by 2 equals 14. This is a little bit different because you guys haven't really seen examples. This is a little bit different because you haven't seen examples with our ratios. Okay, but it's still going to be the same. Earlier, when we had our multiplication, okay, we always divided. Okay, well this time I have division, so I'm going to do the opposite of division, which is multiplication. So I'm going to multiply both sides by 2. Well, 2 over 2 is 1, so I'm going to bring my 1 over here. I know it's really yucky. So So that becomes 1, so I'm left with x plus 2 equals, well, 14 times 2 is 28. Okay, now I got rid of that 2 over there. My x is still here, so I want to keep it there. So finish it out. We're going to subtract 2 from this side, it becomes 0. And subtract 2 from this side. So I'm left with x equals 26.